I needed a simple, offline tool to perform some common PDF operations for my various small business projects here on the Gulf Coast. Things like merging documents, splitting pages, rotating specific pages, and extracting content. I've tried web-based tools before, but the constant uploading of sensitive documents felt like an unnecessary privacy risk, and the offline access was non-negotiable for my workflow. So I decided to build Zeus PDF, a dedicated desktop application using PySide6 for the UI and PyMuPDF, also known as FITS, for the heavy lifting of PDF manipulation. The initial prototype was straightforward enough for the core PDF functions, but I quickly realized that any useful PDF editor absolutely needed a robust undo and redo system. Without it, even the simplest mistake would require redoing an entire sequence of operations, which is just not acceptable for a productivity tool. The heart of handling PDF documents in Python, for my purposes, was PyMuPDF. It's an incredibly powerful library, a wrapper around the C library MuPDF, and it's fast. To open a document, you simply call fits.openFilePath. From there, a document object gives you access to individual page objects, which are the units of manipulation. For instance, to rotate a page, you do page.setRotationAngle. Merging documents involves creating a new fits.open document and then iterating through the pages of other documents, calling newdoc.insertOtherDoc, from page equals start, toppage equals end. Extracting pages means just saving a subset of pages to a new document. PyMuPDF handles the low-level details of byte manipulation and rendering very efficiently. The critical part was ensuring these operations were performed on a copy or a temporary state that could be rolled back, which led me down the path of implementing a command pattern. Implementing undo/redo meant embracing the command pattern. This design pattern encapsulates a request as an object, thereby allowing for parameterization of clients with different requests, queuing of requests, and logging of requests. It also supports undoable operations. I defined a base command abstract class with execute and undo methods. Each specific PDF operation, like rotate page command, merge pages command, or split document command, would inherit from this base class and implement its own logic for both performing the action and reversing it. This meant that every action that modified the PDF document needed to be thought of as a pair, an action and its precise inverse. This foresight was crucial, as an incorrectly implemented undo method could easily corrupt the document state. The command manager class became the orchestrator. It holds two lists, undoStack and redoStack. When an operation is performed, the corresponding command object is instantiated, its execute method is called, and then the command is pushed onto the undoStack. If the user then decides to undo, the command manager pops a command from undoStack, calls its undo method, and pushes it onto the redoStack. The redo operation is the exact inverse. Pop from redoStack, call execute, push to undoStack. This simple stack-based approach provides a robust and flexible undo/redo system. The challenge was ensuring that the state passed to each command was correct, especially when dealing with mutable PDF document objects. I often found myself passing references to the current PDF document, or more often, creating temporary copies of document states to ensure undo could revert to a known good state. A critical detail for the undo/redo to function correctly with PyMuPDF was how I managed the PDF document itself. PyMuPDF's document objects are mutable. If I just pass the main document object around, an undo operation on a later command might conflict with changes made by earlier commands that were not yet undone. My solution involved maintaining a current document state and ensuring that each command operated on a temporary copy or a specific version of the document. When a command's execute method was called, it would receive the current document, apply its changes, and return a new document object representing the modified state. This new document would then become the current document for the UI and subsequent commands. The original document would be held by the command for its undo operation. This copy-on-write-like approach, though memory-intensive for very large PDFs, ensured state integrity. The PySide6 UI was built using Qt widgets, primarily QMainWindow, QList widget for displaying pages, and QGraphics view for previewing individual pages. Connecting the UI actions to the command manager was straightforward. A button click, say rotate page 90 degrees, would trigger a slot that would instantiate a rotate page command self.currentDocument, page number, 90, and then pass it to self.commandmanager.executeCommand. I used signals and slots to update the UI after each command execution, ensuring that the displayed PDF preview and page list reflected the latest state. The Q action objects for undo and redo were mapped directly to self.commandmanager.undo and self.commandmanager.redo, with their enabled/disabled states dynamically updated based on whether the undo stack or redo stack had any commands. One particular challenge I ran into was handling the memory footprint of keeping multiple PDF document states in the undo/redo stacks. PyMuPDF documents, especially if they contain high-resolution images, can be quite large. Storing deep copies of entire documents for every single command could quickly exhaust system memory. My initial approach was to store full fits.document objects in the stacks, which worked fine for small documents, but became problematic for documents over 100 pages with images. The compromise I settled on was to limit the undo/redo stack depth to a reasonable number, say 20 operations, and for very large documents, optimize certain commands to store only the deltas or page indices affected, rather than the entire document state. This meant some commands had to be smarter about their undo logic. Building Zeus PDF was a solid exercise in combining a powerful external library like PyMuPDF with a robust UI framework like PySide6, and perhaps more importantly, designing a resilient application architecture through the command pattern. The undo/redo functionality, which initially seemed like a minor feature, became central to making the application genuinely usable. It demonstrated that for any non-trivial editor-like application, careful state management and a well-thought-out command history are indispensable. Zeus PDF is now a reliable part of my toolkit, handling my local PDF needs without ever touching the cloud. If you've ever grappled with state management in a desktop application or wanted to see how a real undo/redo system can be built in Python, I hope this was helpful. I'll be releasing the source code for Zeus PDF on GitHub soon. Consider subscribing if you want to see more real-world Python applications I'm building.